Alright, this is section 3 of your data project. So I have gone and measured a bunch of my neighbors and things, their finger lengths. So remember my question was, among adults in Kanab, what is the length of your pointer finger in millimeters? So I put their names here, who I measured, and the lengths of their fingers in millimeters. Okay, that's just the way I gathered it. This is not in order yet. So remember, the first thing I taught you was anytime you get your data set is to put it in order from least to greatest. Alright, now this is kind of going to be a pain, at least for mine. I think yours is also printed this way, but it's on the back to organize your data. So I'm just going to find my smallest one and then write it. So it looks to me, now remember you're doing this example in your notes, so you're following along. So let's find the smallest number on here. I think 67 is the smallest finger I've seen. 2 of those. So I got 2 67s. So I'm just going to put a X on them so that I remember. Oh, 64. Look at that. 64 is smaller than the rest of those. I see nothing else. So 64 millimeters is going to be the smallest one. So I'm going to write 64 here. Now we had 2 67s. Those were next smallest. So there's a 67, there's a 67, I've used them up. Let's see, 68, I see one of those. Okay, one of those, so 68. Anything after 68? Nothing else in the 60s, so I'm going to 70s now. Let's see, 79, 78, 71, that's probably smallest. Oh, 271s right there. No 70s. So let's do 271s. I'll mark them off so I don't use them again. So 271s. After 71, I see a 72. I only see one 72. Let's see, 73. I do not see a 73. 74 right here though. And I only see one 74 on my data. And then it looks to me like the next one's 76. So I'm going to put 74 and 76. 74, 76. Let's see what else we have. 77, I don't see a 77 on there. 78, there's one. I don't see any other 78s, but I saw 2 79s. So I'm going to do 178 and 2 79s. 178, 2 79s. Let's see, 80. I've got 180 here. I have an 81. Yes, right there. 81. 82. Oh, it's 84. 83. I do not see an 82, but I got an 83 here. 2 83s here. Let's do that. 2 83s. $86, $84. Oh, I missed a 78. Okay, that's why you should be doing yours in pencil, not pen. I do pen so it shows up better on the video, but that's going to mess me up. 79. Let's see. Maybe I just didn't X it off. Okay, 78. Do I have another 78? Oh, I think we're okay. I did mark 78, but I forgot to mark it off over here. Okay, we're okay. We don't have to erase anything. Got an 86, 84, nothing else. These are the only two not X'd off. So 84 and then 86 are my last ones. Oh, got lucky, but please do yours in pencil when you do this so you don't make a mess up. If not, you can use whiteout, but okay. So we got all our numbers ordered from least to greatest. Now one interesting thing I want you to note, looks like for most of these, looks like those who the boys that I interviewed, the men, seem to have a little bit bigger hands than the women. Just kind of an interesting note. Alright, so now we have our data all organized. We're going to do section 3, which shows data frequency and visual representations. So it says to create a line plot of your data on the number line below. So this number line is blank because we're all going to have different data sets. So like looking at mine doesn't start till 64 and goes all the way up to 86. So I wouldn't want a number 1, 2, 3, 4, 5, 6 on here. I can start at my lowest value, so I'm going to start at 64. And I need to go up about 20. I think I can fit 20 in here. But maybe I'm only going to number by 2s. So maybe I'll do like this, 66, 68, 70. Try to make these as evenly split as you can. I know mine aren't perfect, but try to make them as evenly split as you can. So 74, 76, 78, 80, 82, 84, 86, 88, 90. Okay, there's my fairly evenly split number line. Now because we're doing a dot plot or a line plot, they're both known, they can both be called that. I need to have something to mark the other one, so I'm going to mark a little line in between here to represent those odd numbers, but I don't have to number it because we are smart enough to figure out that these lines in between would count for those. But I do have to have a place for them because a line or dot plot indicates each individual value. Alright, I need a title. What did I measure? So these are lengths of pointer fingers. I think there's a more, I think that's called the index finger, but we'll call it pointer finger, in millimeters. Alright, so I have 164. You can do a dot or an X, whatever you want. I had 267s, 168, 271s, 72, 74, 76, 78, 279s, 80, 81, 83, 283s, an 84, and an 86. There is a simple line plot or dot plot of my data. As you can see just from looking at it, it looks like they're pretty spaced out. I've got a couple that repeated themselves. But for the most part, everybody's hands was just a little bit different size. Okay, now we're going to need this data to do the next page. So we are going to be creating a frequency table and a frequency histogram with labels. Now there's one thing I forgot to add on here. I want you to also make a relative frequency. So I want you to cut this in half. And then I want you to write relative frequency. This was the percentage. So frequency is just how many. Relative frequency is the percentage out of the total. Alright, so intervals. We are going to be splitting our intervals into 1, 2, 3, 4, 5 spaces. So what we're doing is we're taking the number line and we're going to divide it into 5 equal pieces, but we need to see how far we're spanning. So pay really close attention to this. It's not hard. But if I want to find my intervals, we want 5 intervals, so that means I'm going to divide that entire space by 5. So I got to take my highest one, which in my case was 86, and I'm going to so that's the maximum one. The minimum one was 64. And I get a difference of, you may use your calculator, 86 minus 64, now that you can do it by hand, is 22. Now, I'm going to be dividing that up over 5 intervals, so I need to figure out how big each space would be. Now, we got to round it up, no matter what. Even if it's a nice whole number, we always round it up. If not, what happens is you end up leaving out your last number. So, 22 divided by 5 would be 4.4. But we're going to round it up no matter what this number is. We round it up to the nearest whole, so I'm going to round it to 5. So my intervals are going to be 5 units wide. Now, how does that work for our project? That means I've got to start at my minimum one, so 64. And then this one is going to be 5 more. The starting one of this one's going to be 5 more than the last one. So 64 plus 5 is 69. 69 plus 5 is going to give me 74. 74 plus 5 will give me 79. And 79 plus 5 gives me 84. Okay. That was 5 more. So what does this mean? This means this is going to be the start of the next interval. Well, where's this last interval going to end? Well, it's going to end at 68. So, this interval means this span of numbers between 64 and 68. This one's going to span between 69 and 73, because we got to go from 73 to 74 would jump here. From 74 to 78. Now remember, I rounded up to the nearest whole number. If you're doing with decimals, you might do a decimal here. So this would actually probably be 68.9, and then we jumped, because we could have part of a millimeter, but because I measured in whole numbers, this is fine. If you happen to measure in decimals or fractions, then you would go up to the nearest fraction. Anyway, this one here would be 83. And then this one would be 5 more. Notice these are all 5 more than the one before it. So 5 more would be 88. Now what we're going to do is we're going to take our data and find how many fit between there. Since we've already organized our data, this makes it really easy. So 64, I've got one here. If your data was not organized, you could just go through and tally here. 67 fits here, 67 fits here, and so does 68. Okay, between 69 and 73, we have 2 71s, 72, and that's it. 74 would fit in this one. 76 would fit here, and so would 78. Okay, 79 to 83, we have 2 79s. 80, 81, and 83. No, 2 83s. And then up here between 84 and 86, we have 84 and 86. Okay, one thing to check. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 data pieces. We should have 18 total tallies. 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 6 is 16, and 16 plus 2 is 18. Okay, I didn't miss anything. Now, the frequency is just how many tallies, how many were in between those ranges. So in this interval, we had 4 people that fit. In between this range, we had 3. In this interval, we had 3. In this interval, we had 6 people, and in this range, we had 2. Now, relative frequency, you're just taking the frequency divided by the total, which we had 18, and then we're just turning it into a decimal. So 4 divided by 18 equals 2, 2, 2, 2, 2, 2, 2. So round it to the nearest hundredth. That would be 0.22 or 22%. Okay, 3 out of 18. 3 divided by 18 gives me the decimal 1.66666. So that would round to 0.17 or about 17%. This one's going to be the same. Okay, this one we have 6 out of 18. So 6 divided by 18 gives me about 0.33. So this is about 33% of the data. And 2 out of 18 would be about 11% of the data. Okay, so you have just now made a frequency table. Now we're going to make a histogram to go with it. Okay, so you are going to write a title when you're doing your own. This will be whatever your data is. In this case, mine is length of pointer fingers in millimeters. Of adults from Kanab. Alright, so down here at the bottom, our x-axis, we have it already split into 5 sections. Each one of these sections represents our intervals. So our interval started for this one. We're going to put a little squiggle here because it didn't start at 0. But we started from 64 to 68. This one down here, we started at, this was 69 to 73. 74 through 78. 79 through 83. And 84 through 88. Now we need a label here. What was this measured in? This was length in centimeters. Or not centimeters, millimeters. Okay, label our intervals. The y-axis is going to represent the frequency, or how many. Okay, now looking at our frequency, I only need to be able to go up to 6. And I have 1, 2, 3, 4, 5 lines. So I can't number 0 to 6. This one's already 0 down here. So I'm going to number by 2. So this would be 2, 4, 6, 8, 10. Okay, titles, labels, numbering. Now we're going to make our histogram. So between 64 and 68, we had 4 people that fit in that size. So I'm going to make a line up to 4. Remember, there are no gaps between these. There are no gaps between the bars on histogram. So I'm going to go up to 4, and then I'm shading it in. Okay, 69 to 73, we had 3. So I'm going to go up to 3. 3 would be about halfway between. If we want to, we can kind of divide these in half just to see where that would be. So I'm going to go up to 3. And right at 3, I'm going to come straight over and straight up from this. Remember, no gaps. Okay, and then I'm going to shade it. I'm just going to shade it in a different direction so it's a little easier to read here. Okay, from 74 to 78, we also had 3. So it's going to be the same height. I'm going to shade it in the opposite direction again. Between 79 and 83, looking up at our frequency table, we had 6. So I'm going to go all the way up to 6 for this one. And then I'm going to color it in the opposite direction again. And then from 84 to 88, we had 2. And if we like, we can write the numbers above it. So there were 6 here, 2 here, 3, 3, and 4. Now, when you do your own personal one, you might find that you have 12. So you need to number accordingly so that you can make it that tall. Okay, but that's all there is to making a histogram based upon our data.